acknowledging the awardees of our travel grants. That's the Smith Cernan Evans Travel Grant from the from Survey, and the Larry Taylor Travel Grant. But Jack will not be here for that if we held it later this morning, and I would prefer that he would be here. And so we're probably going to postpone that till Thursday afternoon. The next presentation is an ANCSA presentation, and I'm representing the ANCSA team, and it's the ANCSA initiative fulfilling science goals of Apollo 17 and looking ahead to Artemis. If I have next slide, please. Oh, sorry. Yeah, this just gives an overview of both ANCSA and my talk. And we designed, as Dave Draper had mentioned, designed the ANCSA initiative as a low-cost sample return mission, and with several goals. One goal was to essentially complete some of the science that remained from the Apollo program that wasn't really completed in the 1970s. Two, it was to examine these relatively new samples, as I mentioned, like a cheap new sample return mission to the Taurus Littoral Valley. And I'll discuss that briefly, but also it was designed for individuals from multiple generations to meet and talk about samples and interact, and really looking forward to what we can learn about the samples and handling them with modern technologies and how that applies to Artemis. For those who aren't familiar with ANCSA, and I know many of you are, there are three types of samples that we targeted. One is 73001, which is an unopened vacuum sealed sample container that the lower part of the the Station 3 drive tube was placed in this and sealed on the moon and remained sealed until earlier this year. The second target of the ANCSA initiative was the upper part of that drive tube, which remained sealed within the drive tube itself. And again, in curation, I think it was only X-rayed in the 1970s, but again, a brand new sample. And then finally, we had a set of samples that were frozen samples that were frozen soon after Jack's return, probably 3 weeks to 4 weeks after his return in December, and frozen in a freezer at a little over -25 degrees, again, for 50 years. So the ANCSA initiative is looking at these types of samples and using new technologies. As you all know, as Jack showed in the slide, his slide, the double drive tube is from Station 3, which is in that light mantle deposit highlighted by the star next to Laura Crater. And the landslide deposit that is shown there, the light mantle deposit, was part of the target for the mission. And the red circles, those were the locations of some of the frozen samples. Again, we were organized as a sample return team. This in the upper left-hand corner just illustrates the teams initially selected by NASA and the team leads. And these teams essentially formed an umbrella, was organized in an umbrella to cover all of NASA or all of ANCSA's scientific goals. And we've been meeting regularly on the internet, and we actually had our second full team live meeting on Monday and Tuesday of this week. In addition to those lead universities and institutes, we also had a number of collaborators and co-Is from a number of universities. Those are represented here. NASA centers, international space agencies. ESA played a big role in opening up this core sample vacuum container, national labs, and research centers. And again, I'd like to thank the LPI, who have been extremely helpful in piecing and helping with the ANCSA progress and allowing open communication between team members and between the team and the public. Again, this was organized as a sample return mission. I just want to emphasize that again and again. And the science team leads are myself and Francis McCubbin. Our science was guided by a rules of the road document, which is very commonly a document associated with most missions. We had a preliminary examination team prior to COVID, and over 80 scientists, engineers, and curators were involved in ANCSA, and over 35 undergraduates. So early career people were involved in this along many of Apollo age scientists and engineers. This is Apollo plus 50 years. Was this the right time to open these valuable samples? In most cases, I'd say yes. It places the samples within the geological context with new remote sensing data. It provides us with new tools to utilize for curation. This is just an example of an XCT image of the core. And also we have new and improved instrumentation and new analytical systems that we can use on these samples that we didn't have in the 1970s. Where I put a question mark was, it's too bad we couldn't have started a little bit early. Over the last 5 years, we've lost a number of very valuable and influential sample scientists who would have been perfect fitting into this program, or they've retired. And so that's the only regret that I kind of have starting as late as we did in the 20-teens. Luckily, we have Jack. Let me go ahead and just briefly talk about fulfilling Apollo 17 science. One of the major goals of the Apollo 17 mission was to collect and document samples and study lunar surface geology. This goal was achieved, as you could see from Jack's mission. There were several other more specific targets, science targets, that the goals were accomplished on the surface and never completed by the follow-on science. And one was collecting a single core tube sample greater than 1 kilometer from the limb. And that was sealed in the core sample vacuum container. That was never reached to conclusion. The sampling of indigenous gases, which may have been released along the Lee Lincoln Scarp and trapped within the landslide deposit, that was never fully realized. And collecting core samples from the slight mantle deposit were again collected, but never fully realized. The core sample vacuum container and the upper part of that double drive tube, I think our work is illustrating that we are fulfilling the goals of Apollo 17 science 50 years ago, from 50 years later. And this involves some of the work that we've done piercing the core sample vacuum container and more recently analyzing those gases. And there appears to be one interpretation is that there are trapped lunar gases within that core sample vacuum container, at least a component of the gases. There has been an extensive study of the organics in these, which will be reported hopefully later this week. And finally, we have established a stratigraphy for the double drive tube in the light mantle deposit. In addition, there are new science questions that have been proposed over the last 50 years. These are tied to volatiles and the importance of volatiles and the volatile cycle, the evolution of regolith and unique environments, the crust and mantle evolution and origin, tectonics, impacts, and more recently, resources and the utilization of resources on the moon. And again, I think ANCSA plays a role in answering some of these questions. Here are some areas that I think we've made contributions, and you'll see during this whole week, there's been many more. What is the volatile record preserved and the ANCSA samples, and a variety of methodologies, new methodologies have been utilized to address that question. What are the new lithologies within the drive tube telling us about the evolution of the lunar crust? How does the regolith evolve and the lunar landslide deposit and potentially other unique environments such as shadowed environments and permanently shadowed regions? And, another question that hopefully we're attempting to answer is what is triggering the Taurus Littoral Valley landslide movement, landslide deposit? Was it movement along the Lee-Lincoln Scarp or recent impacts? This is the debate that we're trying to answer. Finally, I think ANCSA has a perspective looking forward toward Artemis. How do we collect samples and preserve them, uniquely preserve them and analyze them? And what do new technologies help in terms of PE and enabling science? We've demonstrated that. And then also, let's see, also, what we've essentially done is ask the question, how and when does the science team participate in surface sampling and curation activities? And here's a bunch of, I think, real answers to some of these. One is that they should be embedded early in some of the discussions and decisions made in terms of instrumentation on the surface, and how curation should be done on these samples. Again, a voice. This was a multi-generational team, and multi-generational teams work, and they work very well with regards to the transfer of data and information, both from the early career people to the older Apollo generation people, and from the Apollo generation individuals up to the younger generation. And more than anything, and this was demonstrated primarily by the great curation staff here, training was important, and you train until you drop. There are a lot of scientific diversity, diverse teams really work. And that was illustrated here, not only in terms of a diversity of instrumentation brought to examining these samples, but also combining not only sample observations, but combining those observations with orbital observations, field observations, and geophysics. It adds value to the samples and adds value to the other types of remote observations and surface observations. So again, in any science teams for the future tied to Artemis, we would really consider, it should be considered, a really diverse scientific team. And then finally, a list of ANCSA first. This ANCSA first, the first opening of a specially collected sample in one of these core sample vacuum containers. Only 2 were collected on the surface of the moon. One Apollo 16, one Apollo 17. We developed the technologies and the teamwork to open up this one. The first examination of a core through one of these landslide deposits, which again was a goal of Apollo 17. Completion essentially of the first experiment on the surface of the moon that was designed to collect gas samples released from the interior of the moon. This is the first core sample opened and studied since the 1990s. And and it was the first real integration of studying a core where we integrated a variety of new analytical techniques in the lab and combined them with Apollo generation knowledge. That's all I had for now. And so let's wait for questions after the, I think, fourth talk. The next speaker after this presentation, and you can put on the third talk, is Ryan Ziegler, the curator of the lunar sample collection. Ryan?